Welcome to Chapter 13, where we will be talking about abstract classes and interfaces. This is quite a technical topic, so the videos will definitely be very helpful for this one. The three topics we're going to talk about are abstract classes, interfaces, and then the Java API, learning the comparable interface. So what and why? An interface is for defining common behavior for classes, included unrelated classes. Before discussing interfaces, we introduce a closely related subject, abstract classes. So the main topic of Chapter 13 will be interfaces, but before we understand that, we have to cover the subject of abstract classes. To define something very general or abstract, and then use it in a more concrete way. So you have abstraction, and then you have concrete. To force the class implementing to use these features. So we saw an inheritance where if you inherit a parent class with a child class, the child has all of the features of the parent. They have the ability to use those features, right? They have the ability to use those features. But when you're using abstraction or interfaces, you don't just have the ability, but you are forced to use all of those features. You don't have the option, you are forced to be able to use them. These concepts will be important, especially in the coming weeks when we get into graphical user interfaces. There is inheritance and abstraction and interfaces and all of this stuff in GUIs within Java. These concepts are also present in the use of implementation of interfaces. So let's start off by talking about abstract classes. Abstract in English, the adjective, is existing in thought or as an idea, but not having a physical or concrete existence. So abstraction means a vague understanding of something. In Java, an abstract class in the context of Java is a superclass that cannot be instantiated, meaning we can't make an object of it, and it is used to state or define general characteristics. An object cannot be formed from a Java abstract class. Trying to instantiate an abstract class only produces a compile error, as we will see. The abstract class is declared using the keyword abstract. So, like I said, when we go into the examples, abstraction is going to make a lot more sense. This is kind of just reference material. But going off abstraction from the Java terminology and the English definition, here's some examples I came up with. So the abstract idea would be an animal. If I just say, I have an animal, that's very abstract. You don't know what animal I have. It could be a cat, a dog, a kangaroo, a bird. I could say, I like football teams. Well, that's an abstract idea because do I like the Steelers, the Saints, the Rams, the Jets, or who? Vehicle, I drive a vehicle. That is an abstract term because more concrete would be car, bike, truck, plane, van. What type of vehicle do you drive? Food is an abstract term because you could be more specific or concrete with pizza, salad, chocolate, or toast. So abstract is just the general idea, and concrete is to get more specific. So one more time, abstract is the general idea of something, like how it exists, very generally, and concrete is specific, the specifics of your abstract idea. And like all of my PowerPoints, we have to have some inclusion of SpongeBob. So examples of abstract and their concrete counterparts. We have SpongeBob, but SpongeBob is abstract, right? Just generic SpongeBob. He could be happy, sad, laughing, bored, confused, goofy, normal, so on and so forth. So these are the concrete forms of what SpongeBob could be. We are now going to look at this example called GameObject, which uses player and menu to show you exactly in Java how abstraction works, and then we will move on to interfaces. Before that, just a few notes on abstraction. An abstract class cannot be instantiated using the new operator. So we can't make an object of a class that is abstract, but there are ways around that, as we will see. An abstract method cannot be contained in a non-abstract class. So if you have a method that is abstract, you cannot put that in a non-abstract class. It has to exist in an abstract class. A non-abstract subclass extended from an abstract class. All the abstract methods must be implemented, even if they're not used. So if you have a non-abstract class that implements an abstract class, you have to use all of the methods presented to you. Again, a concept that will make sense when we go over the examples. A subclass can override a method from its superclass to define an abstract. It's rare, but useful when you have to use an abstract class, but maybe there's a method that you don't need anymore, but still you're forced to use it, so you could override it and have it do nothing. Although you cannot create an instance from abstract classes, using the new operator, you can use it as a data type, such as an array. So again, this slide might be a little bit crazy to understand right now, but we are going to define all of these things in code very shortly. So in the next video, we will be doing just that with these examples.